We're given a quartic equation with roots p, q, r, and s, and we're asked, without solving it, to determine a quartic with these roots. Okay, they've all been multiplied by 3, and then had they've been subtracted by 1. You've got to be using a substitution here. It's the most complicated one on the AS or even the A level to do the roots of polynomials for. You won't go into quintics, and it gets quite involved, the calculations. But the substitution would actually be relatively simple, so it's definitely the way to go. So we're going to let w equal 3z minus 1. That means every single point will be multiplied by 3 and then minus 1, so the roots will be as well. And that it will all work out from there. So then z is going to be w plus 1 over 3. We just need to work out what z squared is in z to the 4. But we don't need to worry about z to the 3. So let's definitely do this using, I think, a binomial expansion. Z squared is going to then be 1 over 9 w plus 1 squared, which is 1 over 9 w squared plus 2w plus 1. And z to the 4 is then going to be 1 over 81. Okay, where's my Pascal's triangle? So I've done the 1, 2, 1, 1, 3, 3, 1. So the coefficients for the next one are 1, 4, 6, 4, 1. So that's what we're going to get here. W to the 4 plus 4w to the 3 plus 6w squared plus 4w plus 1. Okay, and let me do this in a different color now. Therefore, down here, a bit more room. 1 over 81 times this plus 5 over 9 minus 30 is equal to 0. We've just got to tie this up now. So the first thing to do is to multiply through by 81. When I do this, I'm going to get, a part of it's going to cancel out with the 9. I'm going to get 45 here. And then 30 times 81, which is 2,430. This here simplifies to 45w squared plus 90w plus 45. So I've got my quartic, I've got my cubic, I've got 6w squared plus 45w squared. That's going to be 51w squared. Then 4w plus 90w gives me 94w. And then I'm doing 1 plus 45 to give 46, minusing 2430. I used my calculator for this bit, got minus 2,384 equals 0. And there we go. That quartic will necessarily have the roots required. This leaves us with part 2. I think this is the best question in the paper because it's a bit unseen. We've got our cubic, but we don't know what n is. And we've got 3 roots. We don't know what they are either, but they are linked. It's not like they're alpha, beta, gamma. We've got alpha, 2 alpha, and alpha minus beta. We're asked to find the roots of the equation and the value of n. So we know that the sum of the roots is minus b over a. The sum of the pairs is c over a. And the sum of the triplets is minus d over a. In this case, there is no sum. Let's just rewrite this cubic. We've got 4x cubed plus 0x squared plus nx plus 81 is 0. This is my A. This is my B, just really emphasizing that it's 0, C, and D. So I know that alpha plus 2 alpha plus alpha minus beta is going to be, well, minus 0 over 4, which is just 0. And that means that beta is equal to 4 alpha. Brilliant. Okay, next one. Alpha times 2 alpha plus alpha times alpha minus beta plus 2 alpha times alpha minus beta. That's equal to C over A, which is N over 4. I'll come back to that one. I could tidy it up, I guess, but I'm going to leave it for the moment. And then I've got alpha, 2 alpha, alpha minus beta equal to minus D over A, so that's minus 81 over 4. Now remember, we just showed that beta was equal to 4 alpha. So then I've got 2 alpha squared times alpha minus 4 alpha, that's minus 3 alpha, is equal to minus 81 over 4, which means alpha cubed is going to be 81 over 24, because I'm going to divide through by minus 6. I'm going to get 81 over 24, the negatives cancel. If I divide top and bottom by 3, I then get 27 over 8, which is a nice cube number, and that gives me alpha equal to 3 over 2. And beta then is going to be 4 times that, is going to be 6. And therefore the roots are 3 over 2 for my alpha. 2 alpha is going to be 3. And finally, I've got 3 over 2 minus 6, which is going to give me minus 9 over 2. This just leaves the value of n, and it's that formula that I'd left. Okay, but now we know what the roots are. Well, we know what alpha and beta are. That's all that's required. So maybe I should just tie this up first, actually, before I substitute in. So 2 alpha squared plus alpha squared minus alpha beta plus 2 alpha squared minus 2 alpha beta is n over 4. That gives me 5 alpha squared minus 3 alpha beta equal to n over 4. And we can then sub in for alpha is 3 over 2, beta is equal to 6. I'm going to put that one on my calculator. So 5 times 3 over 2 squared minus 3 times 3 over 2 times 6 gives me minus 63 over 4. And hence n is going to equal minus 63. Okay, excellent question. Well done.